live. Hello, and welcome to reading group. I had to look over at the monitor. There was a reading group. Oh, one second, make sure everything's muted. And I'm waiting for the stream to catch up. There we go. Okay, fantastic. That's working. Howdy. Good morning. Well, it's morning for me. Today we are going to be reading a paper. And the paper is from the journal, the International Journal of Open Information Technologies, which seems to be mostly an open science / open source. I have my glasses clouds around here anyway. Sorry, I've just been running a little behind this morning. Open science / open source journal. Wow. So the papers are all free to read. You don't have to pay to publish in it, which is usually a sign of a predatory journal or one owned by a major publishing house. Anyway, hello, Nick. Welcome to the stream. The paper is from a couple of Rasa community members who are also researchers on enhancing Rasa NLU model for Vietnamese Chatbot. And I thought this would be a really cool paper to highlight, because we always love to see, Rasa community members doing cool stuff, and B, because Vietnamese is a language that is extremely unlike English. So, well, okay, let me get into that a little bit more. They might talk about this in the paper. I've not read the paper previously, but here's the PDF. This is maybe not the most ideal reading experience. Yeah, I guess I'll download it and then open it in the same download. Anyway, so fun things about, there we go, that's much better. And can I get this gone? I'll make that go away. I don't know that I can make that go away, but that's okay, we'll handle it. So things about Vietnamese. Vietnamese is Austroasiatic. So languages are divided into language families based on the ones that they have, that they share a common ancestor with. So like the Romance languages all come from Latin. Indo-European languages all come from Proto-Indo-European. So that's, English, German, French. The Romance languages are Indo-European. Hindi is Indo-European. So English and Hindi are actually not super distantly related as two languages. But adjust levels, a little bit peaky. Vietnamese is part of this language family that's not super closely related to, any of the languages around it. So it's not super related to, the Dravidian languages, the Indo-European languages of India. It's not super related to the languages related to Chinese. And I'm not going to get too deep into that particular argument because it's an area of sort of active, research and disagreement. And Vietnamese is the largest language in this group, and it has, it's had language contact with, the Chinese languages around it. So it's got tone that no other languages in its family does, like lexical tone. So that probably comes from language contact. There's also a lot of language contact with French due to the colonialism. So lots of sort of loanwords from French. Interesting things about it, it has infixes, which is sort of the reason that it pops up most often in sort of linguistics training materials. So an infix is a little word part that goes in the middle of another word part. In English, kind of the only infix we have, and it's really informal, is using the F word in the middle of another word. So un-effing believable, that sort of thing. And Vietnamese has a lot of those, but it is pretty analytic, which means that word order conveys most of the grammatical information, as opposed to having, small bits of words that come together to convey grammatical information, like German. German is fairly synthetic. Anyway, intro to Vietnamese. It's pretty different from English. I'm really interested to see what they do. Hello, Deepak. Welcome to the stream. And hi, Rishabh. Welcome to the stream. Excuse me. All right, let's hop in. Enhancing Rasa NLU model for Vietnamese chatbot. Let's actually zoom in a little bit more so y'all can see that a little bit better. Abstract. Nowadays, the use of chatbots in industry and education has increased substantially. Building the chatbot system using traditional methods is less effective than applied machine learning methods, sometimes. Before chatbots based on finite state, rule-based knowledge bases, etc. But these methods still exist, still have limitations. Recently, thanks to the advancement in natural language processing and neural networks, conversational AI systems have made significant progress in many tasks such as intent classification, entity extraction, sentiment analysis, etc. Yeah, I would say those are all tasks that people use deep learning for sure. In this paper, we implemented a Vietnamese chatbot that is capable of understanding natural language. It can generate responses, take actions for the user, and remember the context of the conversation. We used the Rasa Platform for building the chatbot and proposed an approach using a custom pipeline for an NLU model. In our work, we applied the pre-trained model's fast text and multilingual BERT and 2 custom components for the pipeline. Okay, so they've got, okay, so they're using Rasa NLU, and then they're using fast text, which is a embedding. And I think I know Vincent messaged me about this. We might have Vietnamese embeddings in the Rasa NLU GitHub repo. And multilingual BERT, the big transformer language model, and 2 custom components for the pipelines. Okay, so they're taking the Rasa assistant and they're adding additional components to the pipelines to make it work for Vietnamese. We evaluated and compared our proposed model with existing ones using the predefined NLU pipeline. So how do their components help? Experimental comparison of 3 models showed that the proposed model performs better in intent classification and entity extraction. Okay, so NLU here means they're not going to be talking about the, dialogue management and picking what to say next. It's all going to be, their contributions are really focused around taking in text and converting it to a machine readable format. And it's a short paper, so we've got 5 pages. Introduction. Ooh, hot coffee. The virtual assistants or chatbots appear more and more in our social lives, such as Apple Siri, Google Assistant, Amazon Alexa, Microsoft Cortana, and Yandex WordStat. I don't think I've heard of WordStat before. It's probably Russian language if it's by Yandex. The virtual assistant can help users perform a variety of requests, from making a call, searching for information on the internet, to booking a ticket or booking a hotel room. Communicating with the virtual assistant via voice or text interaction. So they're just talking sort of about like the use of virtual assistants and chatbots in day-to-day life. Traditional chatbots are built on rule-based systems. So in the input, so when questions outside the script are input, the chatbots will not understand and wait for customer care staff to respond to the user requests, which I think is a pretty common complaint with chatbots, is they don't, I'm sorry, I don't understand. I'm sorry, I don't understand. That sort of response over and over again. Whether a chatbot is intelligent or not depends on the ability to understand user context and work independently. So this is what they're using to, what they're going to refer to as intelligence in this paper. To achieve this goal, chatbots must be built on machine learning and artificial intelligence. In the last few years, many studies using several machine learning methods based on neural networks for building conversational AI systems have sort of shown up. So they're saying being able to handle things said in new ways and new flows of interaction, you're probably going to need to use some sort of deep learning approach. With the advantage of machine learning techniques, the chatbot performance increased. The use of chatbots has shown amazing efficiency in many areas of social life. Chatbots help businesses save costs, manpower, and increase efficiency in customer care, assuming they work, an important caveat. On the user side, there are a lot of people that prefer to interact with chatbots. Oh, let's see the citation for that. That's interesting. So that was paper 5 here. Need to know chatbot statistics in 2020 from chatbot.com. So this is probably some sort of industry survey. And I don't know, there might be some bias for the types of questions asked by chatbot.com, but we can look into that another day. With the launch of several chatbot platforms such as Facebook Messenger, WhatsApp, Telegram, Skype, and Slack, the number of chatbots increases day by day. Recently, the use of chatbots increased not only in commercial, but also in medicinal and educational uses. And there's particularly around, you know, COVID-19 stuff, there's been a lot of chatbots. Jack says, sorry to interrupt, is Vietnamese considered an infrequent language? I mean, I run into Vietnamese quite a lot here in Seattle because there's a pretty large Vietnamese-speaking population. So there's a distinction that people in the NLU community will sometimes talk about high resource versus low resource language. And usually what resource means there is NLP tooling that's been built and the size and quality of available corpora. So the majority of NLP work is done on English because there are lots of very large English language corpora, or collections of texts that you would use as training data. So languages that are not English, you sort of have like a climb down, and the less in Europe they are, basically, the faster or the further down that climb they are. I'm trying to think where like Mandarin would go on that climb, and I'm very much less familiar with the Mandarin language research community, and I know that there's, particularly for NLP work, a little bit of a disconnect between folks who primarily publish in English and folks who primarily publish in Mandarin. Yeah, Jack says, yeah, I'm asking because I am currently working with an infrequent language with few resources. Yeah. So I would say on that sort of like slope, Vietnamese is definitely below like French, probably. I haven't worked with it a whole bunch, but I don't work on French extensively, but I'm familiar with several French language resources. I also don't really work on Vietnamese extensively, and I'm not familiar with a lot of Vietnamese language resources. So yeah, I would say if you're going to talk about languages as being high or low resource, I would call Vietnamese sort of low resource. And I don't know. I've got a lot of thoughts about this as a linguist, because no language is inherently better or worse than any other language. It's just more or less accessible to a certain population. And real talk, I am pretty darn fed up with major research projects that are like, we're doing something new. Oh, it only works if you have like 3 terabytes worth of text data in your target language. I mean, congrats, you work on English. The majority of the world does not speak English. Like, have you really advanced the field if the thing that you do only works on one language? And not like because of the inherent characteristics of that language, but because of the disparity in data availability. Like, I don't know. I don't know that that's really making people's lives better in a meaningful way to the degree that, building a system that allows people to easily, work with their chosen language does, and helping make things more accessible. Anyway, you've triggered one of my trap cards. I'm increasingly frustrated with the English dominance of NLP research. Anyway. Yeah, so I think the big benefit of this paper is that they're going to talk through sort of how they're working with this language, and that you can use their sort of process as a template for your own work. Ooh. Sorry, I'm getting riled. All right, one more sip of coffee. So, how do you build chatbots? Lots of options. Some of the ones you have currently: Rasa, that's us. Amazon Lex, Microsoft Bot Framework, Google Dialogflow, IBM Watson, Twit AI, and so on. In this work, we use the Rasa platform for building our chatbot for these reasons. Rasa is open source. It can be run locally, so you don't have to pay for server time. And it has the advantage of self-hosted open source, such as adaptability, data control, etc. I also think those are advantages of Rasa. Ooh, what's the citation? That's cool. It's evaluating natural language understanding services for conversation question answering systems from the SIGDial Discourse and Dialogue workshop. Okay, and this was from 2017, so a little bit, that would have been Rasa 0.x, and we are now in Rasa 2.x, so the comparisons here are probably not like, I mean, the things I said about Rasa are still correct, but might not hold for the other systems talked about in that particular resource as well. Scroll. In this paper, Jiao describes the principles of Rasa NLU and is that the section we were in? No, this is the section we were in. I was like, I don't remember reading that paragraph. The rest of this paper is structured as follows. Section 2 discusses the existing works. Thank you. I love the related works at the beginning. Section 3 describes the method to build a Vietnamese chatbot with significant improvement in intent classification and entity extraction. We show and discuss the obtained results in section 6, and we close with some concluding remarks and discussion on our future work. Thank you, Jack. And Bazil says, I live for Rachel Rants. Yeah, I don't know. I try not to get too heated, but some stuff just like, you know, it gets to me. All right. There are many tools/platforms for building a chatbot based on natural language understanding. We've implemented our research that uses the most common platform available on the market. Rasa, I don't know, in our projects we might be the most common. I don't actually know that this is true. Rasa is not only a commercial chatbot building platform, but also greatly aids research. Oh, shucks. In previous work, we created our chatbot in Russian, but we haven't used a custom pipeline to improve the NLU model. The NLU model is only trained based on supervised embedding, but not applying modern pre-training models such as Glove, Fast Text, or Bert. So they're just sort of like training their own embeddings from the corpus that they have, and they're saying, hey, we want to incorporate these sort of larger corpora. We want to use embeddings that have been pre-trained on larger corpora in our target language. In paper 8, the authors reviewed and analyzed the Rasa platform in quite some detail. They built a chatbot integrating with the API in the database. However, the study built a simple chatbot without using the advanced capabilities of the platform. Paper 8. Just going to scroll down. And over. An analytical study and review of open source chatbot framework /Rasa in the International Journal of Engineering. I don't think I've read that one. I'm gonna have to, no. I'm gonna have to go through and look at some of their references. In this other paper, Jiao describes the principle of Rasa NLU and designed the functional framework which implemented within Rasa NLU. The author integrated Rasa NLU and neural network methods for entity extraction after intent recognition. So the way that we're doing this currently would be with Diet, which is a multitask learning algorithm for both entity extraction and intent recognition. The study showed that Rasa NLU outperforms neural network inaccuracy for a single experiment. So they're saying this other work doesn't do a large number of evaluations. Recently, Rasa NLU is often used to build conversational AI. It comprises loosely coupled models, combining several NLP and ML libraries in a consistent API. In 11, the author presented examples for using custom components in Rasa NLU in Vietnamese and Japanese. Oh, a little peek at there. And this is Quang Rasa Chatbot. That's in Vietnamese. Custom component, custom tokenization for Vietnamese. And that is from March 2020, so that's this year. Oh, interesting. This is really helpful for me. I'm learning about a lot of work that people are doing. And oh, actually, it looks like there's a whole master's thesis on. I'm sure they'll talk about this. Chatbots. That looks like a loan word. I'm guessing that word is the same as the English word chatbot. chatbots maybe in Vietnamese. I think this is the Vietnamese language. I do not speak Vietnamese. In 11 Vietnamese and Japanese, custom tokenizers for Vietnamese and Japanese, and created a custom sentiment analyzer, too. The results showed the NLU model is more suitable and better for Vietnamese and Japanese. In 12, they presented building a Vietnamese chatbot using the Rasa platform. The author created a custom tokenizer for Vietnamese and trained an NLU model using a supervised method. So all of the previous work has been done on sort of like building little components, not little components, but adding components to the Rasa pipeline specifically for Vietnamese. And then this paper's different contribution is that they're going to be applying pre-training models like FastText, Mighty, Bert in a custom Rasa NLU pipeline. This one is out of MIT. I think we might still have legacy support for it. We've sort of stepped down the degree to which we integrate with it, but definitely something that you can still use. I also don't know how much active development is going on in it either. All right, so what did they do? Method. In this section, we will present the construction of a Rasa chatbot consisting of two main components, NLU and core. And we have since combined those as product names into Rasa open source, but there's still two parts to it. There's the NLU taking in text and turning it into a machine readable format, and then core deciding what to say next. Or do. It doesn't have to just be a dialogue turn. We also propose a method, cannot read today, to improve Vietnamese chatbots' natural language understanding by using custom components in pipelines. In addition, the performance of a chatbot also depends on tuning the parameters and policies provided in Rasa core. So saying that, hey, we improved our chatbot by adding a component, you could also improve your chatbot by spending some more time tuning your model. Rasa Platform. Rasa is an open source implementation for natural language processing, NLU. Okay, so they are going to be using Diet and the dual intent and entity transformer model. So this is a model that we developed for doing NLU. Rasa combines NLU and core. NLU analyzes the user's input, then classifies it into intents and extracts entities. NLU combines different annotators from spaCy to parse and interpret the input data. And I don't know if spaCy supports Vietnamese. So intent classification, interpreting meaning based on predefined intents. Example, how many people are infected with COVID-19 in the USA is a request cases intent with 97% confidence. And this would be an intent to ask about the number of cases. And then entity extraction, recognizing structured data. Example, USA is a location, and that is looking at a text string, identifying which characters in the string belong to an entity and which entity that is. Rasa core takes a structured input in the form of intents and entities and chooses which action the chatbot should take using a probabilistic model. Figure 1 shows the high-level architecture of Rasa. So it's absolutely true. I would say that it also uses the history of the conversation and other example conversations from the stories. So message in goes to the interpreter, and then from Rasa.com, Dax NLU. I think this is more of a 1.0 thing, but it's still like correct. So it's sent to the tracker. The tracker is what stores the whole history of the conversation, all the information that's been extracted. The policy decides what to do next. An action is taken. That action may or may not be sending a message to the user. It could be like triggering some code. It could be just waiting and listening for the user to say something. Whatever the assistant does is added to the tracker and also, if required, sent back to the user. Oh, that's literally what they're going to say right here. I should read before I just talk through things. The process of how Rasa core responds to the message is explained as followed. The input message is passed to the interpreter, Rasa NLU. The interpreter converts users' messages into a structured output, including the original text, intents, and entities. Scroll. The tracker follows the conversation state and receives the appearance of a new message. So it's just like a database file gets added to the database. The output of the tracker passes into policy, which receives the current state of the tracker. The next action is chosen by the policy. The tracker logs the chosen action. The response is sent to the user using a predefined utterance in NLU.md. And this would be for 1.x as of 2.x. It would be YAML. Yeah, I know we're also a little bit more flexible about where things go, but it can also go in the domain is where you could define your utterances. Processing Rasa Pipeline. The process of the input message includes different components. The components are executed sequentially in a processing pipeline. The component processes the input and gives an output, which can be used by any of the following components in the pipeline. A processing pipeline defines which processing stages the input messages will have to pass, and in what order. They don't say that, but that's also true. The processing stage can be a tokenizer, featureizer, named entity recognizer, intent classifier, etc. Rasa provides pre-configured pipelines, which can be used by setting the configuration values as spacey scikit-learn, mighty scikit-learn, keyword, TensorFlow embedding, etc. Besides, we can create a custom pipeline by passing components to the NLU pipeline configuration variable. Figure 2 shows the schema of intent classification. So we have the input, which goes through a pipeline. So tokenizer broken into smaller pieces, featureizer, those smaller pieces are converted to numbers, entity extractor, entities in the text are identified and saved to a structured format. Intent classifier, the whole intent will be detected. Nick says, Rasa core processor only returns the next actions and event. I think that's working as intended. I'm not sure if this is like you giving me helpful information, in which case thank you, or this is a bug, in which case I would either post about it on GitHub or the forum. It's sort of hard to judge from just text, unfortunately. We were talking about it, right? Okay, so it must be the giving more context for this processor. And then you get the intent classification and the entity out. Oh, asking if it does. I'm not 100% sure. I would check in the API specification. I would do it right now, but I do want to get through this paper today, and I don't want to get too sidetracked, and I know if we go to the docs, I'm going to get too excited by the docs, and we'll stay there for the rest of the time. So yeah, I would check the API specs. All right, so sort of general process of intent classification and entity extraction. To build a good NLU, Nick says it has action listen. Yeah. You might want to check the part in the docs about predefined actions or built-in actions. That's what they're called. They'll tell you more about action listen. I do want to answer your question, but perhaps tomorrow. Trying to keep myself a little bit more on target. Or you can always ask on the forum as well if you have additional questions. All right, so they're adding additional things. They're adding a sentiment analyzer, a tokenizer, a spell checker, etc. Custom component. Components make up the NLU pipeline. They work sequentially to handle the user's input text into a structured output. In this work, we create 2 custom components. Okay, so they do a Vietnamese Tokenizer and also a fast text featurizer, which Rasa NLU doesn't currently offer. I think there's something about fast text and NLU. I'm gonna see if I can find it. It also, they might have been working on this paper before that came out as well, which is very possible. Let's see if I can find it. Would help if I spelled literally any of those words correctly. Yeah, so we do have, and again, this might have come out after they wrote their thing. We do have a fast text featurizers in this Rasa NLU examples repo. So something that we've been working on is trying to make it, you know, it easier to work with languages other than English in Rasa. So adding, you know, the languages that are supported by fast text has been one of the things that we've been doing there. So that might be a good first step if you're working on something like this yourself. And it looks like they've also done that. And then a Vietnamese Tokenizer. So I mentioned that Vietnamese does have slightly more affixes, like parts that go on words than English does. Most languages do. English is pretty impoverished when it comes to morphology. So being able to break words down into all their component parts is language specific. And they're using the Vietnamese toolkit Under the Sea. The fast text featurizer is a dense featurizer which helps load the fast text embeddings, which have been pre-trained. The implementation of the featurizer requires a tokenizer that is presented in the pipeline. So if you're going to be using, you know, these features, you need to make sure that you're using the right, like the same tokenizer that they were trained on. Rasa has pre-configured pipelines, which we review for building the chatbot. Tensorflow Pipeline, Convert, and these are ones that were recommended in the 1.0 docs. One of the big changes between 1.x and 2.x is that we have started just like, you don't have to mess with your pipeline right out the box. We just sort of like provide one that should work for most folks, at least to get you started, and then you can go back and tune it for your needs. And a Bert-based pipeline. The TensorFlow-based pipeline can be used to build the chatbot from scratch. It doesn't use pre-trained word vectors and supports any language that can be tokenized. When we use a custom tokenizer for a specified language, so here they have the ISO language code, we can replace the tokenizer whitespace with our tokenizer, which is more accurate. Figure 3 shows an alternative Vietnamese tokenizer in a TensorFlow-based pipeline. So language Vietnamese, the Vietnamese tokenizer, and then they're doing named entity recognition using conditional random fields. I think that's what CRF stands for. People generally just say CRF, and then count vectors featurizer, and then TensorFlow embeddings for the classifier. The custom pipeline is a list of the names of the components we want to use. We proposed a custom pipeline, CP Fast Text, using a Vietnamese tokenizer and Fast Text featurizer for loading pre-trained word embeddings in Vietnamese from Fast Text. Rasa doesn't natively support Fast Text, so we need to create a custom featurizer for Fast Text and add it into the pipeline. We can download the pre-trained model for Vietnamese from Fast Text citation. The model with 4.19 gigabytes in binary compression, so it's pretty hefty. I guess if you're serving like a large chatbot, that's not a whole bunch to hold in memory, but if you're trying to do like embedded systems, that might be a little bit more space than you have in your code attic. Figure 4 shows the custom pipeline using fast text for Vietnamese. So this is the TensorFlow-based one, and this is one where they are also adding their own featurizer. Very similar, Vietnamese tokenizer, the featurizer. Okay, so here they're using a count vector featurizer, here they're using a lexical syntactic featurizer, and then count vectors, and then they're using their additional fast text featurizer using their downloaded model that they're pointing to here. Oh, and they're also talking about convert. So Convert Pipeline is a template pipeline that uses a convert model to extract pre-trained sentence embeddings. Convert was trained on English. It was trained on English Reddit data. And I actually don't know that we're still supporting it because there was some problems with the data, not the data, the model availability. So Jack says, since they're using Spacy, why not create a custom Spacy language tokenizer and use Rasa Spacy Tokenizer? That's a great question. My guess would be because the Spacy Tokenizer wouldn't match the same tokens as the fast text embeddings require. So, you know, the sort of the process is you do the tokenization and then you look up each of those tokens in your your library of fast text embeddings. But if they're slightly different and it's not right, it's not necessarily like different tokenizers will decide that the breaks are in different places, or you know, one of them might be able to handle diacritics, which are very important in Vietnamese, sort of like the sprinkles on the text, and another one might not be able to, or they might handle them in slightly different ways. So because they want to use fast text, their choice of tokenizer has to be the same tokenizer that the fast text model expects. But if you have your own embeddings, you can, if you're training your own embeddings, you can of course use any tokenizer you like. And if you're using different pre-trained embeddings, then you need to make sure that you have the same tokenizer that was used to train them. This is, I would say, top 3 places where people run into trouble. And you'll know I think probably the most common error message is you'll get something about a dimension mismatch if things have gone sideways there. Or it just not existing, like it'll look it up. Or sometimes it'll be replaced with all zeros. So should be a dense vector and it looks like a sparse vector. There's lots of ways it can go wrong. Yep, and then they mentioned that they can't use convert because it only supports English. And then looks like some tofu there, so I think that's supposed to be a different character. Which, yes, also, again, not super available right now. Also trained on Reddit data, which take from that what you will. We also consider a pipeline using state-of-the-art language model BERT. Rasa provides the pipeline with a configuration for BERT using Hugging Face. It can be configured with a BERT model inside the pipeline. The example pipeline is shown here. I do really like that they have little example pipelines in the text. I think that's really helpful. So you have the Hugging Face transformers, and then they're looking for the BERT-based multilingual case. And so Hugging Face is another startup that focuses on NLP, and they support a lot of the transformer models. So you'll be linked to it from our docs, but if you're looking for more information on this model, the Hugging Face documentation is a better place for it. And then tokenizer, featurizer, count vector featurizer, and then a diet classifier. We will implement the experiment and compare the above pipelines in section 4. So our pipelines that we're going to be working with are the sort of baseline, I would call it, Vietnamese Tokenizer, the fast text version, and then the BERT version. And this is the version of BERT that was based on multiple languages. And then they have a bunch of core policies. They discussed the different core policies. Some of them are rule-based, some of them are machine learning policies. So the TED policy, which is our sort of the one that I would recommend at this point. The memoization, which is a transformer-based policy. The memoization policy, which says, hey, look at my training data. If the same thing is happening, keep doing the thing that happened in the training data. Jack says, thank you for supporting Hugging Face, making our lives easier. Yeah, they're mostly pretty good folks. I think Thomas Wolfe at Hugging Face and I have like fundamentally different visions of the future of NLP, but not like in a bad way. I think he's just a lot less cynical than I am about sort of the ceiling of NLP. Memoization policy, the augmented memoization policy that yesterday during the office hours, Ella talked about quite a bit. So it's it's similar to the memoization policy, but instead of sort of holding the whole thing in memory, it sort of has like almost like an RNN for get gate. It has a sliding window and it'll sort of like chop things off the conversation beginning and end to try and match what's happening now. Rule policies. So this is new in 2.0. I get the sense that they were working on this as we did the 2.0 release. So it looks like they're probably using 1.0 maybe for some of their experiments and for other ones 2.0. And I don't think that should be a problem. But I would double check the documentation before using one of their pipelines just to make sure it's still supported. The rule policy, which is a 2.0 thing, and then configuration, so how much of the conversation do you look at, how much data augmentation do you do, and then what featureizers. The policies are configured in config.yaml. 2 parameters, mask history, and data augmentation affect the performance of the model. The policy used affects the performance of the model. So we need to review and tune the parameters of the policies and be able to use the policies in tandem. Yeah. And usually you'll use a number of policies together. They'll all provide a confidence value. Usually the memoization policy, when it applies, is extremely confident because it is basically a type of rule. Whereas the TED policy is usually a little bit less confident, but is able to handle more new things. I don't know, hopefully that makes sense. Let's get into these experiments. In this work, we experimented in a data set that includes 40 intents, 8 entities, and 1,000 examples. That's a quite a large number of intents. The intents and utterances are stored in NLU.md. Okay, so this... Okay, so it looks like so just what I'm noticing here is that some of their files are MD, some of them are YAML. So I'm guessing that during the course of this work, they upgraded to 2.0. The stories of conversation are in stories.markdown. The pipeline and policies are in config.yaml, and the domain.yaml file defines the domain in which the chatbot operates, so things it knows about. The domain specifies the intents, entities, slots, utterance, responses, actions, and a configuration for conversation sessions. We specify the expiration time of a conversation session is 60 seconds. So that's pretty fast, but I'm guessing that because they're doing experiments, they want to do a lot of conversations. So the shorter expiration time is to make it easier to run multiple things. And the reason I say it's pretty fast is that I will oftentimes spend more than 60 seconds trying to type a reply, especially if I'm trying to not have typos. We created 2 custom components, the Vietnamese Tokenizer and the fast text featureizer. You could also use the one that we made. As described in section 3. We used 3 pipelines. So we got the Tensorflow, the Vietnamese fast text, and the Bert Pipeline. And we just talked about all of these. For the Bert one, they use Bert multilingual base model cased, so uppercase and lowercase things are treated as separate. They're pre-trained on top of 104 languages with a Wikipedia dataset. And based on the citations and the tiny little snippets of Vietnamese in the citations, I think case is grammatically important in Vietnamese. Again, not a language that I'm deeply knowledgeable about. Therefore, we will compare the proposed model with the 2 base models, TensorFlow and Bert, that are configured using existing components from Rasa NLU. All right, let's see the experimental results. So they're going to be using precision, F1 score, and accuracy. So precision is, they got the little equations. Wow. Took me a while to remember what that word was here. So precision is the number of true positives divided by the number of true positives plus false positives. Recall is the number of true positives divided by the number of true positives plus false negatives. Precision, F1 is the harmonic mean of precision and recall. And then accuracy is like how many you got right over all your guesses. And that's what they're saying here. We evaluated the intent classification by F1 score, accuracy, and precision using cross-validation. This is very thorough. I would probably just report the F1 score and then go into a more detailed error analysis. But I appreciate the thoroughness. The results on 3 models in Table 2 show the micro-average scores on the test set for intent classification and entity extraction over 5-fold cross-validation. Based on their number of intents and training examples, I would be surprised if intent classification did super well. Just because more, depending on the distribution of your data, training data, in general, more intents is harder for a model. Nick says it's the same as classification report. Oh yeah, we report that. Yeah, usually, particularly, this is a journal paper, so I think they have a little bit more leeway, but particularly for conference papers, space is at a premium, and people will pick like one metric. 5-fold cross-validation. For the results, the proposed model is the best model for intent recognition. F1 score 86%, accuracy 86%, precision. So pretty good. And entity extraction, F1 81%, accuracy 99%, precision 86%. And the MBERT model gives the worst results. It can be explained that because the dataset is not large enough, 1,000 examples, and applying MBERT, 5-fold class validation. Nick asked how many folds they were doing. Here it is, 5-fold cross validation. Yeah, good question. So they're saying that BERT probably isn't appropriate because they have a small training data size, and TensorFlow model gives better results. So looking at the results, I'm wondering why just this line is bolded. Okay, so just this line is bolded because this is the highest F1 score across the 3 models, the TensorFlow model, the BERT model. Wow, the BERT model did bad. So this is a 60% or 0.6 F1 score for intent classification, and then 0.7 F1 score for entity detection, which is actually better than the TensorFlow model, but for classification it did extremely poorly. Interesting. Which would be very frustrating as a user, right? If your intent is misunderstood 60% of the time. Sorry, if your intent is misunderstood like 35% of the time-ish, that would be frustrating. Is how I would do that. But also having low intent recognition is also frustrating. And accuracy is higher because if intents are rare and you're pretty good at picking them out, if intents are rare and you always, if entities are rare and you always guess there's no entity, you're going to be right most of the time, which is why F1 score is appropriate. Yeah, but I would say that their FastX model, like, very definitively is doing the best of these 3 models, so that is good. Nick says, BERT needs more data, that's why I like it less. Yeah. Which, I mean, if you are, you know, say, the company Google and working on the language English, more data is not a problem for you. If you are the majority of people working in NLP, it probably is going to be. People in Google love to talk about things being Google scale, by which they mean real big. Yeah, and then so they use the built-in testing, which is why they've reported all the scores. Very helpful. So the models were evaluated on the test set, and the F1 score for each exclusion percentage is recorded. So how much data is put in the test set. Wow, Bert did bad. Wowee. And interestingly, the TensorFlow did not do that much worse, but I would agree that with these results that, like, yeah, I think it's pretty clear that given these three pipelines, the Vietnamese Tokenizer and fast text really is giving them the best improvement. Jack said, yep. Yeah, and so one thing that might, so we were talking about how more data is better. If you look at sort of the curve of improvement for the number of examples, as you can see, over time, BERT continues to go up without a lot of decay in that growth rate. Even though, you know, the TensorFlow and the fast text models see quick improvement with smaller numbers of data, and then the growth rate tends to decay pretty good. And it could be that they're just getting towards ceiling on this task because they're sort of in the mid 90s. But you can imagine if you sort of continue these lines on their current trajectory, as you add more data, eventually perhaps this BERT line would come up and be above these two lines. But you would need, you know, maybe like a third more data, assuming this rate is consistent. We created plots of intent prediction confidence distribution for the three models. That's the next plot. The plot with 2 columns per bin showing the confidence distribution for hits and misses. The plot of CP fast text model shows that most correct prediction confidences. Thus, the results show the model's CP fast text using the proposed method have given the best results for intent classification. So we've chosen the proposed CP fast text model to build the chatbot. See if we can see figure 7. Okay, so what you... Interesting. Interesting. So what this is showing is this is confidence down here. So confidence is a measure the model returns of how well the given example maps to the category examples that it's been given. Basically, there's an NLP for developers video on it that goes into more detail. And the confidence for the misses for the TensorFlow model is pretty straightforward. And the confidence for the hits for the TensorFlow model is much higher. And then for the CP fast text model, it is like stark. It is super, super, super clear. So when it is right, it has high confidence. And then the confidence is sort of like uniformly distributed from, I would say, like 0.3 to 1 for places where it misses. And then for the BERT model, when it misses, it has really low confidence, but it's almost uniformly distributed. I mean, checking out this last histogram bin, it's almost uniformly distributed from around 0.3 as well when it's wrong. Yeah, interesting. So this to me says this is underbaked, so it just needs more data, more time. But again, do you have that? It depends. Interesting. Yeah, no, I agree with their selection of model. So we evaluated the dialogue model using Rasa Core. We used the TED policy. Fantastic. That's what I'd recommend in this case. Memoization policy and a fallback policy, and set the max history to 5, NLU threshold to 7, and core threshold to 2.5. So this is when your model isn't super sure about what you said. Confidence is below 0.7, that's when you'd hop back to, I'm sorry, I didn't understand you. Core threshold, if your confidence is below 0.5 in what to do next, that's when you'll hop down to whatever your policy is there. The confusion matrix of the actions presented in figure 8. It is in figure 8. Evaluation on the conversation level and action level on 3 metrics, F1 score, accuracy, and precision, same as they were doing before. The results are presented in table 3. So let's pop on down. to table 3. So this is very small, and I don't think zooming in is going to help a whole bunch. I'm actually going to zoom out. So it's a confusion matrix. The true labels are the rows, and the predicted labels are the columns, and I cannot read the labels very well, and it doesn't matter a whole bunch, because what you want to see is low and 0 or no fill for things off the diagonal, and high numbers and lots of fill for things on the diagonal, and this is like pretty much textbook in terms of what you want a confidence matrix to look like. And you can tell that some things on the diagonal are, you know, darker and some things are lighter, and that's just because they have uneven distribution of their classes, and that's fine. But that's a nice result. That's what I like to see. I would be very happy to see this on a project that I was working on. And yeah, look at these. Oh, it's maybe too high. I don't know. It's maybe too high. This is so good that I would be even a little bit worried about it and would want to give it more weird data to see if I could get it to go down a little bit. Really, really good. Jack says, it's weird they didn't analyze the training phrases before conducting research. So checking cosine similarity between training phrases of different intents and the like. So would this be like, interesting. So you're saying that what you would like to see before they do this is an analysis of the data set that they're working with, yeah. But I guess the thing is, like, if you have written your intents well, right, and you've designed your intents well, things within the same intent should have a really high cosine similarity. They should be easy to automatically identify, and things from different intents should be pretty different. So I guess one of the big differences between building a chatbot like this and doing something like a Kaggle competition is that you're probably going to get better results from doing something like redesigning your intents, which we're doing tomorrow in our live streaming, and changing what the classes are rather than, you know, doing parameter tuning. I don't know why that's my signal for parameter tuning. Yeah, so like I think it's perfectly reasonable to keep changing your intents until they're very easy to predict, as long as part of doing that changing and assigning, you include actual user data, because people will surprise you. People will always surprise you, and it's, you know, it's a delight. But also you need to be able to handle that with your system. Nick says, what's the standard threshold? So thresholds for like fallback policy. Yeah, also this very dark one here looks like action listen, which is every time that the assistant's like, time for the person to say something. It will really depend. What I would say, there is no standard threshold. In general, the more training data you have, the fewer intents that you have, and the fewer actions you have, the higher your threshold can be. The more intents you have, the less training data you have, the more different things that your model needs to do, the lower your intent should be. And that's just sort of because you know, what the machine learning policies you're doing is they're assigning some sort of probability distribution over, you know, each of the intents or each of the actions that could be taken. And, you know, if you have 100 intents, which is a lot of intents, you know, if even if a very small probability is assigned to most of them, the highest confidence is probably going to be smaller than it would be if you had 3 intents, if that makes sense. So that's one of those things that I would recommend tuning, and it just sort of depends on you and your data set and your assistant. Yeah, I hope that helped. I like, if you're just looking for a number to start with, 0.7 is pretty good. Would be my very unscientific number I picked out of a hat. You probably want it to be over 0.5. Again, just sort of like generally. But that one you are probably going to want to tune as things go on. conclusion. Man, that's something, huh? In this paper, we presented the method to, thanks. I'm glad I could help. I know it's frustrating that the answer to the question is it depends so often. And this is something that I am really... I'll finish the paper and then I'll talk about it. In this paper, we presented the method to improve the performance of a chatbot using custom Rasa NLU pipeline. Using custom components is appropriate for NLU models in non-English languages or English languages, but I think more urgent in non-English languages. As the results, the proposed model showed the best results in intent classification and entity extraction. And it worked better than the Tensorflow model or Bert. The dialogue model Rasa Core got an accuracy of 95% on the conversation level and 98% on the action level. I think what I would do if I were them, I would probably exclude the action listen. So that's the action that like the assistant is now waiting for the user to say something, because that occurs with such high frequency, right? That's going to occur once per turn. And I think you're less likely to get that wrong than picking the correct utterance to say next. So that would be my recommendation for them going forward for system evaluation. The future scope of this study, we built a model for Vietnamese spell checker, based on neural machine translation, and use it as a new custom component in the NLU pipeline. Looking forward to that. That sounds fun. We will also combine our chatbot with a question answering system based on the Bert model for answering non-predefined questions, so open-ended questions. That could work. That could also be super dangerous, because large, language generated by neural language models is deeply unpredictable and is going to include, false information and slurs, and like, I wouldn't do it, but I could see why it's an interesting research topic. Nick says both NLU and core. Oh, for the threshold? Yeah, I'd say 0.7 is like a reasonable thing. I mean, the number of intents is not going to, right, so if you have more intents, that's going to make I would have that affect your NLU threshold. It wouldn't necessarily need to affect your core threshold. If you have more things that your assistant can do, more actions, I would say that would probably affect your core threshold, but not your intent threshold, if that makes sense. Yeah, and what I was saying about it depends. I've been really thinking lately about how to, I've been working with language data for Jiminy Cricket. I just did some math over a decade. Wow. Anyway, yikes. It's not yikes, it's good, but like over that time I've developed a lot of intuitions that just like came from experience, and how can I help other people get those same intuitions without telling them to go like look at corporate for a decade. Don't do that. Nobody needs that, unless that's what you're passionate about. Yeah, so that's something I've been thinking about, how we can, grow together. Yeah. So back to the paper. Very interesting paper, really nice system evaluation. I find I really like that they tried different components. I think this is a pretty good use case of the fast text featurizers being really useful for languages that have them. 157, which is, I don't know what the languages are, the 157 languages, and I would say that in my experience, big multilingual projects like this tend to have varying quality from language to language, so I would definitely, take it with a grain of salt. Working in your particular language, fast text might not be the best choice. The TensorFlow models might be better. And it looks like unless you have like a lot of data, the BERT models are probably not going to be the best choice. And this is just really, really helpful. Certainly for me, because I knew about the multilingual BERT, and I think it's, again, just based on this one sample, I'd probably want to do some more work for myself. I would say maybe until you have like 1,000 examples in there, it's probably not going to be in contending for the best choice for your pipeline. if you are seeing the same sort of pattern. But now that we have what's the word? Sorry, I've got to go to the Rasa blog because I cannot remember the word. Incremental. There we go. My mind was like, it's intermittent, it's intermezzo, it's interstitial. I was like, it's not that. Incremental training, which means that you can do checkpoints with your model and you can like stop training and then keep retraining. You wouldn't have to train a different model to figure out each of these time points. So like a given time point, you can like stop, check in with it, see how it's going, and be like, yeah, okay, I want to keep going, and then just continue training from where you left off. Obviously, you're not going to be able to do, you know, as much. It should save you time, is what I'm saying there. Yeah, Nick says, thanks for the paper. It gave me lots of ideas and reference links. Yeah, thank you for joining. And thank you to the authors as well. I'm really happy that we're, you know, we're enabling researchers, and it makes me feel really good. And I think this is a really helpful paper. And I definitely like know which pipeline I would choose for a Vietnamese Rasa model now. So I would say, yeah, I think the only thing that I would change for this paper is I would maybe, well, no, because I do want to, I was going to say, I don't know that they needed the core part, but that's like, you do want to make sure that the whole model works well together if you're going to be building a chatbot and not just an NLU system. So no, I think they did need it. Anyway, good paper. I enjoyed it. I think it was super helpful. Thanks for writing it, authors. And yeah. So we will be back tomorrow with live coding, and I'm going to be redoing the intents for the assistant that we've been working on, and I've been doing a little bit of, a very little bit of work on my own to sort of like get a gauge of the information space. Yeah, and we'll work on that tomorrow, same time. Jack says, useful for CDD methodology, so we continuously integrate our logs. Yeah, you should be able to like, you know, take your trained model and just sort of train on top of it. Fine tune it, if you will. So, all right. Thanks so much for joining, everybody. I hope you enjoyed the paper. I certainly did. And I will see you tomorrow. So have a great day.